Is paper 4-3, winter 23. Question 1. A particle is projected vertically upwards from horizontal ground with speed of u meters per second. The particle has a height s meter above the ground at times 3 seconds and 4 seconds after projection. Find the value of u and the value of s. So let's just draw what's happening. There is a ball that's being projected upwards, and we know when something is projected upwards, its path will be something like a quadratic curve, right? And the question states that when t equals to 3 and t equals to 4, the height above the ground is the same. So we can consider something like this height. This is s, and t equals to 4, t equals to 3. The ball is moving upwards here and downwards at this point. So now that I have an idea of what is happening, I'll just decide which equation to use. They've given me the time 2 times, and they've given me a variable for the height and speed. So let's use the equations of motion, SUVEC. The equation I'll be using is S equals U times, I'll just write the formula, S equals UT plus half AT squared. So when t equals to 3, S equals to 3u plus half, the value of a will be 10 as always, times t squared, so 3 square is 9. Now you can think about one thing, which is since u is upwards, we know that acceleration will be acceleration due to gravity, which is downwards. So it will be 3u minus half AT squared. So we'll have to use a minus, not a plus, because u and g are in opposite directions. In that case, 3u minus half times 10 times t square, which is 9. So this is equation 1. Now I'll write equation 2. Equation 2 is almost the same, just t equals to 4. So s equals to 4u. Again, u remains in the same direction because u is the initial velocity. So the direction remains the same, and acceleration also remains the same. So they're again in opposite directions. So again, I'll use a minus half times 10 times 4 square is 16. So 4u minus half times 10 times 16. Now we notice that in both cases there is s equals to something. So I can just use simultaneous equations to solve. So the equation will be something like 3u minus half times 10 times 9 is just minus 45, since 5 times 9 is 45, equals to 4u minus half times 10 is 5, 5 times 16 is 80, so minus 80. Therefore u equals to, if I take 3u to the right, 4u minus 3u is just u, and if I take minus 80 to the left side, it's 80 minus 45, which is 35 meters per second. That is the value of u. They also asked us to find the value of s. So I'll just substitute u in one of those equations. I'll use the first equation. So 3 times 35 minus half, or I could just write the value, which is minus 45. Now I'll just use my calculator to solve. So s equals to 3 times 35 minus 45, that is 60 meters. So the value of u is 35 and the value of s is 60 meters. This is question 2. A machine for driving a nail into a block of wood causes a hammerhead to drop vertically onto the top of a nail. The mass of the hammerhead is 1.2 kilograms and the mass of the nail is 0.04 kilograms. See the diagram. It's given over here. The hammerhead hits the nail with a speed v meters per second and remains in contact with the nail after the impact. The combined hammerhead and the nail move immediately after the impact with a speed of 40 meters per second. Calculate v, giving your answer as an exact fraction. So what's happening over here is we have two masses, the hammer and the nail. Hammer and nail. The nail is at rest initially, resting, and the hammer is moving. So what we can understand is they are colliding. They collide. Note that you don't have to write these in words. This is just for the explanation. So the hammer is colliding with the nail, and after they collide, they move with the speed of 40 meters per second. So therefore, this is a question of momentum. Therefore, question of momentum. In that case, we know the momentum before and after are equal. So before equals to after. I'll just write in short. The momentum before will be completely due to the hammerhead. So 1.2 times 4 times v, the speed we're going to find, is equal to the combined mass. So 1.2 plus 0.004 times 40. So the momentum before is equal to the momentum after. Now I'll just solve for v, so I can just divide the right hand side using 1.2. So 1.200, I can simply write that as this. So this is equal to 1.204 times 40 divided by 1.2. So they told us to write it in an exact fraction. So the answer is 602 by 15 meters per second. The units are not necessary. So moving on. Nail is driven 4 centimeters into the wood. Find the constant force resisting the motion. Now we need to understand what is happening. Since the hammer and nail collide, they move at a speed of 40 meters per second. 40 meters per second downwards. And when they're moving downwards, understand that a mass is losing height. Mass losing height since it's moving downwards. And we know that when a mass moves downwards, GPE is lost. But we also need to understand that when it's moving downwards, it loses its speed. Since when it stops, its speed is 0. Stops. Therefore, KE lost. So both GPE and KE is lost. Kinetic energy is lost. In that case, all the work is being done against the resistive force. Work done against resistance. So since GP is lost and KE is also lost, all the work is done against resistance. So using that, I can form an equation of GPE plus KE equals to work done against resistance. Against resistance. And I know the formula for work done is just force times distance. GPE is nothing but mgh and KE is just half mv squared. So mgh plus half mg squared equals to force times distance. They're asking us to find the constant force. The distance is the 4 centimeters that it is being driven into the wood. So now I'll start forming the equation. The mass we'll be using is the combined mass of the hammerhead and nail. So 1.204. So if I can take m common, so 1.204 times g is always 10. The height they're moving is 4 centimeters, so 4 by 100 meters, SI units. So plus half times the speed is 40, so 40 square. This is equal to F times, again, 4 by 100. So now we are solving for F, right? So let's just simplify first. So our 1.204 times 10 times 100 plus half times 40 square. So the right hand side is a decimal. 963.6816 is equal to 4 by 100, or let's just write it in decimal, 0.04f. Right. Therefore, f is equal to 963.6816 divided by 0.04 equals to 24092.04 newtons. And that is the answer. This is question 3. A block of mass 8 kg slides down a rough plane inclined at 30 degrees to the horizontal starting from rest. The coefficient of friction between the block and the plane is mu. The block accelerates uniformly down the plane at 2.4 meters per second. Draw a diagram showing the forces acting on the block. So it's a pretty simple diagram, to be honest, and we'd have to draw the diagram regardless of whether they asked or not. So just a slope. We'll show the angle, which is 30 degrees. Sorry about that. So a 30-degree angle for the slope and a block of mass. So I'll just draw a block like this. Block of mass 8 kg slides down a rough inclined plane. Forces acting. So its weight 80 newtons. And then there's friction. Since I don't know the value yet and they haven't stated the value either. And of course the normal reaction force. So normal reaction force. Note that you might be tempted to draw or show the force down the slope, but remember that it's just a component of the weight. So if you're showing the weight, you don't actually need to show the component downwards the slope. So I can just write weight in brackets just to be safe. So the diagram is pretty much complete. Then I move on to the question, which is finding the value of u. We need to understand that u is the coefficient of friction, so F is equal to mu r. So to find mu, I'll need to find r eventually, the normal reaction force. And for that, it's as simple as 80 sine 80 cos 30. So r equals to 80 cos 30. So that is done. And then what's happening? The block is accelerating downwards. So acceleration equals to, or the very basic formula, F equals to ma, mass times acceleration. So a equals to force by mass. This force is the resultant force, of course, resultant. So the resultant force is equal to the downwards component of weight, downwards, or I just write mg sine theta minus friction since this is downwards and this is upwards, opposite to the component. This divided by m, that is acceleration. So now we can input the values. Acceleration was 2.4 meters per second square. This is equal to mg sine theta. Mg is 80 sine 30 minus friction. Friction in this case will be 80 cos 30 times mu divided by the mass. The mass was 8 kgs. Now it's just rearranging the equation and making mu the subject. So 2.4 times 8 is 19.2. 19.2 minus 80 sine 30, so which is 40. So 19.2 minus 40 equals to minus 80 cos 30, which is minus 40 mu root 3. So mu is equal to 40, 19.2 minus 40. So minus 20.8 divided by minus 40 root 3. Therefore, mu is equal to 20.8 divided by 40 root 3. So the answer is 13 root 3 by 75, which is rounded to three significant figures, 0.300 approximately. So that is the value of mu. What basically happened is we know the acceleration of which is 2.4, and the formula for acceleration is nothing but resultant force divided by the mass. And the only forces acting on the block are the weight and friction. So the component of weight we are going to use is mg sine theta, the one downwards the slope, and then friction is opposing that component. Friction is equal to F equals mu r. R is 80 cos 30. So after that, we just input the formula and the values accordingly and solve for mu. So mu is equal to 0.300. And now they ask us, find the speed of the block after it has moved 3 meters down the plane. Now the easy part is they've given us the acceleration of 2.4 meters per second square. And they've given us a distance, and they've also stated that u equals to 0 since it started at rest. So I can just use v squared equals to u squared plus 2as. It's as simple as that. So the speed after it has moved 3 meters down the plane. So v squared equals to 0 plus 2 times 2.4 times 3. Therefore, v equals to root over, I'll simplify, 2 times 2.4 times 3 is 14.4. Therefore, v is equal to root over 14.4. So it's 3.79 meters per second. This is question 4. A car has mass 1600 kg. The car is moving along a straight horizontal road at a constant speed of 24 meters per second and is subject to a constant resistance of magnitude 480 newtons. Find in kilowatts the rate at which the engine of the car is working. Rate of work is just power. So they're asking us to find power. Power equals to force times velocity. And since it's moving at a constant speed, the force we are going to use is the resistance. So P is equal to 480 times V. The V is 24. Now, understand that when we're using the formula, they're going to give us the answer in SI units. SI unit of power is watts. But they asked us to give the answer in kilowatts. So to get the answer, we divide by 1000. Therefore, P is equal to 480 times 24 divided by 1000. So it's 11.52 kilowatts. Moving on. The car now moves down a hill inclined at an angle of theta to the horizontal, where sine theta equals to 0.09. The engine of the car is working at a constant rate of 12 kilowatts. The speed of the car is 24 meters per second at the top of the hill. 10 seconds later, the car has traveled 280 meters down the hill and has a speed of 32 meters per second. Given that the resistance is not constant, use an energy method to find the total work done against the resistance during the 10 seconds. So there is a lot of information to process this question. Let's draw roughly what's happening. Then the car, I'll draw a circle to represent the car. Car moves down. The engine of the car is working at a constant rate, so there's a driving force. Driving force, and as always, there's resistance. And they gave us information regarding the speed and the distance traveled. So in 10 seconds, it traveled 280 meters downwards and the speed increased. So I can say that kinetic energy gained. And since it's moving downwards, GPE lost. And they're asking us to find the work done against resistance. So the very basic formula for energy conservation is energy lost equals to energy gained. And another thing we forgot to mention is work done by engine, since there's a driving force. So now that we have pretty much all the energies required, we can start to form an equation. So the work is done by the engine. So since work is done by the engine, we take the power, 12 kilowatts. So that's 12,000 watts. The time is given. So power times time, P into T is equal to W. So times 10. This is the work done by the engine. And since GPE is lost, that is also converted to the energy gain. So I can take GPE in the left hand side of the equation. So GPE is just mgh. This is an inclined plane. So mgh. So the formula we'll be using is mg times s times sine theta. Or like if you actually solve the d sine theta would be more appropriate in this case. So mg d sine theta, d is just the distance traveled or the length of the hill. So 280. So mg, the car's mass was 1600. So 1600 times 10 times 280 sine theta, the value of sine theta is given, so 0.00, so 0.09. So these are the energy lost, the work done by the car engine and the GPE lost, and all of this is gained as kinetic energy and work done against friction. So first the kinetic energy, half mv square. So half times m. Since it's kinetic energy gained, we will subtract the new velocity with the previous velocity. So 32 square minus 24 square. So this is the kinetic energy gained. And lastly, the work done against resistance. So I'll just write W for that. So going through it again, this is the work done by the car engine. This is the GPE lost. This is the kinetic energy gained, and this is the work done against friction, the one we are finding. So now let's just simplify and solve for W. So for the left hand side, it's 12,000 times 10 plus 1600 times 10 times 280 times 0.09. So that's 523,523,200 equals to half mv square. So half m times 32 square minus 24 square. So that's 358,400 plus W. Therefore, W equals to 523,200 minus 358,400. So that's 164800 joules. The work done against resistance. This is question 5. A light string AB is fixed at A and has a particle of weight 80 newtons attached at B. A horizontal force of magnitude Pn is applied at B such that the string makes an angle of theta to the vertical. See the diagram. It is given that P equals to 32 and the system is in equilibrium. Find the tension in the string and the value of theta. We know that at equilibrium, resultant force is 0. Resultant force equals to 0. And since resultant is 0, all the components are also 0. And they said that when P equals to 32. So let's just put 32 like this. Now, what are the forces acting on the particle? The forces acting are the weight, the force P, and of course the tension. Now, the tension is at an angle theta, which they have asked to find. And since tension is at an angle, it has two components, obviously. It has a vertical component and a horizontal component. The vertical component, I'll use a different color for that. The vertical component cancels out the weight, and the horizontal component cancels out the force P. So I need to form equations for the vertical and horizontal component. Since it's a right angle triangle and T is the hypotenuse, with respect to angle theta, the vertical component is T cos theta. And with respect to angle theta, the horizontal component of tension is T sine theta, since it's opposite to the angle, whereas the vertical component is adjacent to the angle. So T cos theta and T sine theta. So now if I'm forming the equation, I know that T cos theta is equal to the weight 80 and T sine theta equals to force P, which is 32. Now we know that sine theta by cos theta is tan theta. So I can write that. So T sine theta by T cos theta is equal to 32 divided by 80. The t's cancel out and sine by cos is tan. So therefore, tan theta is equal to 32 by 80. Let's simplify that. That is equal to 2 by 5. Now I can find theta very easily. Therefore, theta equals to tan inverse 2 by 5, which is roughly equal to tan inverse 2 by 5, which is roughly equal to 21.8 degrees. Note that all answers in degrees must be to one decimal place, not more. So theta is 21.8. Find the tension in the string and the value of theta. So the tension is just the resultant of the vertical and horizontal components, or we can consider it as the hypotenuse of the right angle triangle. So T square equals to, or T square equals to 80 square plus 32 square. Therefore, T is equal to root over 80 square plus 32 square. Therefore, T is equal to root over 80 square plus 32 square. So 16 root 29, if I take it to 3 SF, it's 86.2 newtons. So I found the tension and the value of theta when P equals to 32. Moving on, it is given instead that the tension in the string is 120 newtons and that the particle attached at B still has a weight of 80 newtons. Find the value of P and the value of theta. Now, if we go back, we'll need to make some adjustments to the diagram. This time, P is not given, but the vertical component will still remain T cos theta. Horizontal component will still be T sin theta. Since we now have a value of T of 120, we can make adjustments to that and write 120 cos theta and 120 sin theta. And the weight remains the same. So they're asking us to find the value of P and the value of theta. Since again it's at equilibrium, the resultant force is 0. Resultant force equals 0. Therefore, components also 0. In that case, it's quite simple to solve since weight is countered by the vertical component of tension. So 120 cos theta is equal to 80, or cos theta is equal to 80 by 120. Therefore, theta is equal to cos inverse 80 by 120, which is 48.2 degrees. I have theta, now I can solve for P, or alternatively I can just use Pythagoras to solve. So 120 square is equal to 80 square plus P square, since it's still a right angle triangle. So P square is equal to 120 square minus 80 square. Therefore, P is equal to root over 120 square minus 80 square. Let's just give an arrow line like this. Therefore, P is equal to root over 120 square minus 80 square. So it's 40 root 5, which is roughly 89.4 newtons. So P is 89.4. The new value of theta is 48.2. This is question 6. A particle moves in a straight line. At time t seconds, the acceleration a meters per second square is given by a is equal to 36 minus 60. The velocity of the particle is 27 meters per second when t equals to 2. Find the values of t when the particle is at instantaneous rest. This is a question of kinematics. And what we need to find very first is an equation for v. Equation of v. So v is nothing but integration of a with respect to t. So let's integrate the equation of a. So integration 36 minus 60 dt, or v is equal to 3060 minus 6t square by 2 plus c, or v is equal to 3060 minus 3t square plus c. And they have stated that when t is equal to 2, v is equal to 27. We'll use that information to find c. So 27 is equal to 36 times 2 minus 3 times 2 square plus c. Now let's just simplify and rearrange. So 27 equals to 36 times 2 is 72 minus 3 times 2 square So 60 plus C. Therefore, C is equal to 27 minus 60. So that's minus 33. Now, if you write V is equal to 3060 minus 3t squared minus 33. That is the equation of V. That's only the first part of this question. Now they're asking us to find the values of t when the particle is at instantaneous rest. Instantaneous rest means V is equal to 0. Instantaneous rest, V is equal to 0. I'll use a different color to solve that. So minus 3t squared plus 36 minus 33 is equal to 0. Let's take a minus common to simplify the equation. Minus 3 common to simplify the equation. So 3t squared, this will become minus 12, this becomes plus 11 equals to 0. Now simplifying further, or we can now apply the quadratic middle term factorization. So t squared minus 11t, sorry about that, minus 11t minus t plus 11 equals to 0, or t minus 11 minus 1 common, t minus 11 is equal to 0, or t minus 1, t minus 11 equals to 0. Therefore, the values of t are 1 second and t is equal to 11 seconds. Moving on, find the total distance the particle travels during the first 12 seconds. So, if you're going to find the distance traveled, which is not a vector, so any displacement or displacement that we get with a negative sign must be considered with a modulus. So let's just integrate the equation of V, obviously, since integration of V is equal to the distance or the displacement. So integration, and the equation of V we found was minus 3t squared plus 36 minus 33. So minus 3t squared plus 36t minus 33dt. We missed a t in the previous question. So s equals to minus 3t squared plus 36t minus 33 dt. Now just integrating it. So minus 3t cubed by 3 plus 36t squared by 2 minus 33t plus, let's write k this time. Now let's check if there is any information regarding the value of k. There is no information, so let's just keep k as it is. Now, when solving these questions with instantaneous rest, the trick to find the total distance is by setting the limits. So first distance we'll be finding, first distance, or let's make it even more clear, let's draw the graph or what's happening. The velocity time graph, obviously. So the velocity time graph, they gave us minus 3d squared, so it will be something like, let's make it a bit, so let's use a different color. So the value of t is 1, 11, this is v, this is t, so 0. So we can see that there are a few distances that we need to find. Let's just shift off over here. We know that area under velocity time graph is displacement. Area under vt graph equals to displacement. But what they asked us is for the distance, total distance. So let's check. This is a negative area, this is positive, and again this is negative. So the negative areas must be considered positive. So we'll take a modulus for those values. And the positive area is positive, so that doesn't matter. So our set of limits that we'll be using is 0 to 1, 1 to 11, and 11 to 12. Now understand something, that this graph is symmetrical since it's a quadratic graph. And the thing about being symmetrical is, for the same distance, for let's say 0 to 1 and 11 to 12, we are going to get the same area. So for 0 to 1 and 11 to 12, area is same. So same. So we are only going to integrate and put limits twice, for 0 to 1 and 1 to 11. After that, we can just multiply this with 2 to get the area of 11 to 12. So let's solve. So after simplifying the S equation, so this is minus t cube plus 18t squared minus 33t plus k. For the first one, which is 0 to 1. So after putting, when we're going to put 0, obviously the whole thing is just going to be 0, and so we can just input 1 and get it done with. So minus 1 plus 18 minus 33 and a minus 0 just for the sake of it. So this S, let's consider it S1, equals to minus 1 plus 18 minus 33. So minus 1 plus 18 minus 33, which is negative and expected according to our graph. But we'll consider it as a modulus and take it as 16. And then for S2, the limits will now be 1 and 11. So I can write the integrated equation, minus t cube plus 18t squared minus 33t integration 11 and 1. So for 1, I know that the value will be minus 16, so I can skip that. I'll just focus on inputting 11. So when it's 11, it's minus 11 cube plus 18 times 11 square minus 33 times 11 minus 16. So simplifying, minus 11 cube plus 18 times 11 square minus 33 times 11, that gives us 484 plus 16. So that's 484 plus 16, 500 meters. And we know that 11 to 12 S3 is the same as S1, so it's equal to minus 16. Therefore, total distance is equal to 16 times 2 plus 500, so that's 532 meters. This is question 7. Particles A and B of masses 2.4 kg and 3.3 kg respectively are connected by a light inextensible string that passes over a smooth pulley which is fixed at the top of a rough plane. The plane makes an angle of theta with the horizontal. Particle A is on the plane, and the section of the string between A and the pulley is parallel to the line of greatest slope. Particle B hangs vertically below the pulley and is 1 meter above the ground. Coefficient of friction between the plane and A is mu. Part A. Given that theta is equal to 30, and the system is in equilibrium with A on the point of moving directly up, show that mu is equal to 1.01 correct to 3 significant figures. So there is a lot of information to process, but thankfully they've given us the diagram already. So for part A, this angle is 30 degree, and one thing they've mentioned is that the system is in equilibrium, so the resultant force is zero. Resultant equals to zero, and A is on the point of moving up. Since A is on the verge of moving up, friction will be opposite. So friction will be downwards. Another force that is going to be downwards is, of course, the component of weight, which is mg sine theta. That is given. And then the forces that will be upwards, let's choose a different color for that. So the force that will be upwards is, of course, the tension. The tension will be in the same direction, or like pointing towards the same point. So if tension is upwards over here, tension will also be upwards for B. And the weight of B is downwards. So this is pretty much all the information we need for A. So now let's form an equation. We need note that tension is equal on both sides. That is a fact. So if tension is equal, the equation will be something like tension is equal to the weight of B. So that's 3.3 times 10, so 33. Now I can just use that to substitute in the second equation. So tension, which is 33, is equal to mg sine theta plus friction. And mass of A is 2.4, so I'll just write that directly. So 2.4 times 10 times sine 30, they've already given us the angle, mg sine theta plus friction. So let's use different colors for that. Friction F is equal to mu R, and R is equal to mg cos theta. So mu times 2.4 times 10 times cos 30. Let's change the color of this. So the downwards component over here, downwards component, friction is equal to tension. Now it's just about rearranging the equation to make mu the subject. So let's start simplifying. So 2.4 times 10 times sine 30 is equal to 12. So 33 minus 12 is equal to 2.4 times 10 cos 30. So that's 12 mu root 3, or mu is equal to 21 by 12 root 3. Therefore, mu is equal to 21 by 12 root 3 is roughly 1.01. Sure. So that is part A. This is quite simple. We just use the fact that resultant force equals to 0. So tension equals to weight component mg sine theta plus friction. And we use the diagram to determine the direction of forces. Moving on, part B. It is given that theta is equal to 20 and mu is still 1.01. The system is released from rest with the string taut, which means tension is still present. Tension. Find the total distance traveled by A before coming to instantaneous rest. You may assume that A does not reach the pulley and that B remains at rest after it hits the ground. So this is going to take a lot of information to solve. They've given us theta, so let's fix the diagram accordingly. So 20. The direction of tension will remain the same. Since the angle is decreased, the tension will change. Friction will also change since theta has changed. So all the forces will change, which is why the system is no longer in equilibrium. And we need to find the acceleration when B is still moving, since this will be acceleration 1. So let's just find that first. Acceleration when B is moving. So let's think about it. Acceleration equals to 4 F is equals to mass times acceleration, right? Resultant force. The resultant force will be equal for both. Resultant force will be the same. Since they're connected by the same string, will be the same. Sorry about that. Since their resultant forces are the same, their acceleration will also be the same. So let's start forming an equation. So for B, the only force acting on it is its weight and tension. So its weight should be 3.3 times 10, so 33. So 33 minus T is equal to 3.38. That is for B. Now for A. For A, again, the forces are tension, mg sine theta, and friction. Friction will now be mg, will be F equals to mu r, so mu times mg cos theta, where theta is 20 and mu is 1.01. So let's form an equation. Tension is upwards and the rest are downwards. And since A is moving outwards, so T is positive, minus mg. We could take mg common, to be honest. So if mg is common, what was the mass? The mass was 2.4. So that's 24 mg sine 20 plus mu r. So mu is 1.01, and since r, so cos 20 is equal to 2.48. Now what I did over here is basically a shortcut of mg sine theta plus mu mg cos theta. Basically, I took mg common and then wrote sine theta plus mu cos theta inside the bracket. So rearranging the equation to make t the subject, since I'll need the acceleration first. So to make t the subject for B, t is equal to 33 minus 3.38. And now I can just attempt to solve the equation. So 33 minus 3.3a minus 24 sine 20 plus 1.01 cos 20 is equal to 2.48, right? Or let's make a the subject. So 2.4 plus 3.3, 2.4 plus 3.3 is 5.7. So 5.7a is equal to, in this whole equation, so 33 minus 24 sine 20 plus 1.01 cos 20. Therefore, a is equal to the whole thing divided by 5.7. So 33 minus 24. I'm keeping it as exact as possible so that we get the correct answer. Because if we round over here, there might be an error due to premature rounding. Therefore, a is equal to just 33 minus 24 sine 20 plus 1.01 cos 20 5.7 divided by 5.7. So the acceleration is 0.35322. I'll take it as exact as possible. So this is the first acceleration when B is moving. But we know that B will eventually come to a halt since it's moving a height of 1 meters. So after traveling 1 meters, B will stop. B stops. And when B stops, the tension is no longer present. So T is equal to 0. And when T is equals to 0, the only forces acting on A are mg sine theta and friction. Both are opposing the motion. So A will decelerate. A decelerates. And they asked us to find the total distance traveled by A before coming to an instantaneous rest. So firstly, obviously it's going to travel 1 meters when B is moving. What we need to find is the distance traveled after B stops, and then we add it. So for this acceleration and this distance, we need to find the new speed, or the speed of A when B stops. When B stops. So to find that, since they're starting at rest, I can use the formula v square is equal to u square plus 2as. Since they're starting at rest, u is 0, so what I need is v. So v is equal to root over 2 times a. A is 0.0353222, 0.353222, and A is S is 1, so writing or not writing doesn't really matter. So 2 times 0.353222. So the speed is 0.8450 meters per second. This is the speed after B stops, or when it hits the ground, basically. So with this speed, I need to find the new deceleration. Finding the new deceleration is pretty simple. I'll just take the forces mg sine theta and mu mg cos theta. So for that, I'll just use 24 sine 20. Again, I'm taking mg common just to make it simpler. Cos 20 divided by the mass, since acceleration is resultant force divided by mass. Mass is 2.4. So our new deceleration should be 24 sine 20 plus 1.01 cos 20 divided by 2.4. So our new deceleration is 12.911. So that is the deceleration. Of course, there will be a minus we need to add when solving. So now we have the velocity and the deceleration. We need to find the distance until it's at instantaneous rest. So at instantaneous rest, velocity is 0, so and v square, so technically we don't need this value, we need what's inside. So 2 times 0.353 times 2.0353 222. So 2 times 0.353 222. So that's 0.706 444. V square equals to u square minus 2 times 12.911 times s. We need to find s. So s is equal to 0.706444 divided by 2 times 12.911. So 0.706444 divided by 2 times 12.911. So s is equal to 0.0274 meters. So the final answer, the total distance, therefore total distance equals to 1 plus 0.027 is equal, which is equal to 1.027. If we want to round it to 3 SF, we can write 1.03 meters. That is the answer.